Hello, in this example, we want to find the rank of A, the row space, and the column space. So we have A. A is a 3 by 4 matrix. So we've got 3 rows and 4 columns. So we've got a 3 by 4 matrix. And let's first of all find the rank of A, and then we'll talk a little bit about the row space and the column space. So to find the rank of A, we need to essentially take A and RREF it, giving us the following form: 1, 0, 0, negative 11 fourths, 0, 1, 0, 5 fourths, and the third row 0, 0, 1, 5 fourths. And the number of leading ones is 3. And so this tells us that the rank of A is 3 because we have 3 leading ones. Next, we want to talk about the row space. So let's talk about the row space. So the row space of A, notice that the rows live in R4. So the row space of A is a subspace of R4. And this is because each of our row vectors, we've got 3 row vectors, R1, R2, and R3. Each of the row vectors is an element of R4. And so the row space is essentially the span of these vectors, each of which live in R4. So we've got some subspace of R4. Now we certainly don't have all of R4 because we only got 3 vectors, so we certainly cannot get all of R4. But we know what we do get. So let's write down a few facts so far. So since the rank of A, this implies that the dimension of the row space, let me give ourselves, the dimension of the row space is 3. So the rank of the matrix, that gives us the dimension of the row space. So we already know that we have a dimension 3 space. Well, you know what? We've got 3 vectors. We're talking about a space that has dimension 3. It must be the case that all 3 of these vectors form a basis, right? We need 3 vectors to form a basis for a 3D space. So we could go right ahead and grab those vectors as is. If you're a little bit nervous about doing that, another way to proceed is to examine the reduced row echelon form of A. And this reduced row echelon form of A looked like the following. And so the non-zero rows of RREF of A, these 3 vectors form a basis for the row space. So we've got various ways of expressing a basis for the row space. So let's write down a couple of answers. So one basis for the row space would be the set of vectors 1, 0, 0, negative 11 fourths, another vector 0, 1, 0, 5 fourths, and the last vector 0, 0, 1, 5 fourths. So those are 3 vectors that live in R4, and they do form a basis. You could go through and check linear independence and that they span. Another basis, so another equally good basis, for the row space would be the three vectors that we started with. And so that would be the set 1, 2, negative 1, 2. There was a vector, a 3, 4, 1, 6, and a 5, 4, 1, 0. And the reason we know that that's a basis, we know that we have a row space with dimension 3. We started with 3 vectors. We need 3 vectors to span the space. And so there we go. And you could go through again and check linear dependence in the span, but we've already essentially done that with our calculations so far. The last thing we were asked to do was to examine the column space. So let's make a little bit of room here. So lastly, let's examine the column space. So the dimension of the column space is also 3. And again, this is because the rank is 3, and the rank tells us the dimension of the column space and the dimension of the row space. All right, so we know that our column space is 3. And a quick way to figure out the column space is look at A. Let's see, A was the vector 1, 3, 5 in the first column, 2, 4, 4 in the second, a negative 1, 1, and a 2, 6, 0. And then the RREF version of A, so when we put this in reduced row echelon form, we got down to another matrix here. Let me just write it down quickly. And you can find the dimension of the column space by just looking at the columns where you have these leading ones. So my first 3 columns have these leading ones. That tells me that these first 3 columns, it tells me that those first 3 columns are a basis for the column space. Now remember that the column space lives in R3. It is dimension 3, and so it's all of R3. So one way you could represent the basis for the column space would be to say, hey, it's these columns corresponding to the columns with my pivots, or the columns with my leading ones. Another way of writing down an equally good basis for the column space would be to say, wait a minute, my column space is a subspace of R3 with dimension 3. And the only vector space in R3 with dimension 3 is all of R3. So it must be R3. And we know lots of legitimate bases for R3, one of which would be our favorite basis, 1, 0, 0, 0, 1, 0, and a 0, 0, 1. So basis is not unique. It just needs to span the space and be linearly independent.